Okay, so what we have here, a rectangle has a length of 2 root x and a width of x. So just draw your rectangle. I reckon we'll find this very easy. Okay, 2 root x on the length, root x on the width. Find the area of the rectangle. Okay, we're going to multiply. The length of the diagonal is root 45. Excuse me, don't mean to be mockingly laughing too much at it. Pythagoras' theorem equals 45 squared. Okay, so 2 root x squared plus root x squared equals 45 squared. Root 45 squared, so excuse me. Okay, so root 45 squared is, as we all know, is going to be 45. Now, 2 root x squared is going to be 4x. Root x squared x equals 45. 5x equals 45. X equals 9. Alright. Expecting you to clean up there. The area of a square is twice the area of the rectangle.
So you find the area of the rectangle.
Alright, so we are, so the area of the rectangle would be, it's 2 root 9 by root 9, isn't it? Because x is 9. So what's 2 root 9? 6. What is root 9? 3. So the area of the rectangle is 18. Therefore the area of the square we're talking about is 36. Square has the same length and width. So y equals 6. The length of one side of the square is 6. Everybody alright with that? Okay. 30 now. When I haven't done it in the book, over the book itself in pencil, it means required a bit of thinking. So number 30, what we do with 30 is this. Just going to make the diagram just that bit bigger. Okay, so I'm just going to draw my own diagram part. Or will I? Yeah, I have an idea. Okay, so well, if we were to put this as part of a circle, okay, and I'll try and match the circle to the arc here. Just about there, right? So it was part of a larger circle. You agree with that? Okay. PQ is a chord, and T and M being the midpoint of PQ. Okay. Now what has to happen is, because M is the midpoint of Q, when I link T to M, that has to go through the centre of the circle. Everybody agree with that? You learnt that in the circle chapter. That when you bisect the chord, how do we know it's bisecting? It says PM equals MQ. Means they're the same length. Okay? That one's a different length. Okay? Now, so what that means is there's a centre of the circle C down here somewhere. What I'm next going to do is I'm going to link C to P and Q. Like so. Now, it says PQ is 36. I can half 36 to get 18. Okay. It also says TM is 12. Okay. And calculate the length of the radius of the disc. Alright. So, here's what I'm going to do. I'm going to call this little length in here x. Do you see that length there? I'm going to enlarge this. The problem is with these questions, sometimes you just make the diagram too small and it becomes really hard to read. So, lucky for me, I have a way out of that. Okay, so, okay, we get the gist, right? So this here is x, that's 18. I'm just going to get rid of the points because the points are just clogging up everything at the moment. Okay, now would everybody agree that the radius is this here?
Yeah.
So radius squared equals 18 squared plus x squared. What's the problem with that? Okay, radius is also equal to what? Somebody tell me.
X plus 12.
There you go. X plus 12 squared equals 18 squared plus x squared. I'm not going to go through that. Get it out, and you're just going to multiply it out. Everything will cancel nicely, and you're going to get 24x equals 180. X equals 7.5. Now that's the value of x. Is actually not the value of the radius. Radius is 12 plus x, which is going to be 19.5. Bit random. Took a bit of outside the box thinking there. Okay, so you need to have a look at that again and just remember the trick. Okay, so 30 is important. 32. These ones, I have to say, these ones I struggle at just by being a maths teacher. Alright, just the visual stuff just roots my brain the wrong way. So the diagrams A, B, C, F. We can all see A, B, C, F being the bottom one here. Bottom parallelogram. Grand. A, C, D, E. What's it? A, B, F, E is this one here. Happy with that? And then finally, the last one being A, F, E. What? No, sorry. A, C, D, E. So this one here. So they're the three parallelograms we're talking about. Okay. Now, the area of AFE is 15. So let's look at AFE. It's 15. Okay. What does that automatically mean about this one here? AB, ABF, 15. Because a parallelogram, the area is bisected. So when you have a parallelogram on its own, I'm sure you know this already, but just in case you don't, when you have just a generic parallelogram on its own, anytime I draw, if I draw this way, the area is cut in half. If I draw this way, the area is cut in half. Okay? So if I know the area of one triangle, I know the area of the parallelogram, therefore. Okay? So, what that also means is that this here is 15.
Yes.
Happy enough with that? Now, the tricky part comes in is when I'm trying to figure out what the rest of it is. Okay? So, state clearly why AFB must be 15 square units. What do we state clearly? AEF and the triangle ABF are the same size. They are congruent triangles because they are both part of the same parallelogram. You could go through the whole SSS process if you want. You could say that AE equals BC. I wouldn't say it's necessary, but if you had extra time in your hand, AE equals BF, and then you have AB equals EF, and then you have a common side, AF equals AF, and there you go. There's your two triangles being congruent by SSS. Okay, and you'd say opposite sides of a parallelogram and common side. Okay, now that you've done that, okay guys, find the area of the whole thing. Okay, so how do you find the area of the whole thing? So, what did I do last time?
75.
It is 75, but any idea why it's 75?
Because ACE, the area of that is 30. So then.
So give me a second. A, C to E. How are you guaranteed that's 30?
Because the length of AFC, or the area of AFC must be the same as AEF as well because of SSS.
Just give me a second. Okay. Okay, what way did I do this yesterday? Just 1 second.
We know that ABF, the area is 15.
So we knew that ABF is 15, that's the black triangle. We now know that because of congruent triangles, ACF, which is the red dotted triangle, is also 15. ACF is the same size as, or is a congruent triangle to anybody? AFE, just give me a second. AFE, which is going to be now in blue. So we know that to be 15 as well. Therefore, the two of them added together, 30, which means the other side has to be 30. And finally, the triangle we left out, 15, which is the green region here. So 15 plus 15 plus 15 plus the 30, 75. Not as easy as it looks for me anyway. Okay? Easier for some people than others. Now, okay. Find the perpendicular distance from D to the line EC is 6. Find AB. That's actually really easy. So let me show you what we're going to do there. So we're just going to mark exactly what we're looking for here. We're asked to find AB. AB is here. AB is the same length as FC. FC is, we know that the line D to EC, so we're going to relate D to EC. So I'm going to expand this to EC. EC is double, anybody? EC is double AB. You happy with that? Now, the perpendicular distance has to be off at 90 degrees, so it's going to be something like that. Remember half base by height? So, a half, the green line, I'll now do it in green, half EC multiplied by H has to equal 30. Half of 6, somebody said 6, didn't they? So that's going to be 6, which is 3 EC equals 30. EC therefore equals 10. Go back to the original question. AB therefore has to be 5. That's half it. Okay. Everybody alright with that? Okay, moving on. 35. How did I do 35? Oh yeah, quite easy actually. Bit different, but reasonably easy. Okay, I'm going to draw two circles. I'm going to take them out separately in a second. So circle 1, that's a small circle. Just going to grab it here, up. Grab that, bring it out. Okay, then we're going to have the big circle, which is going to be that one there. Once again, grab that. Okay. Okay, so what we have here is basically our two circles, okay? So I'm going to start working on their areas. I have to prove that the area of one of them is twice the other one. Okay? So I have to prove that the area of the big one is twice the area of the small one. Okay? Sorry? No. Big circle twice small circle. Okay? Work on small circle. Small circle has a diameter of diameter equal in width, equal to the width of the square. You happy with that?
Yeah.
Okay. So what I'm going to do is this one here. I'm just going to call the whole thing D, and therefore the area is pi r squared over 4.